Okay, so what we have here is a DC power supply that is set up to deliver 9 volts direct current at a set point of 0.42 amps. This will be measured using a multimeter as well as delivering the load via these alligator clips. Now that is a copper chloride solution. Now we will be using these 2.7 millimeter lead sticks for a mechanical pencil. So that is actually made of graphite as the electrodes. Now this is just a piece of cardboard that has the 2 sticks just stuck through. So I will be setting those in there, and you can notice the spacing of the electrodes is wide enough that they are not going to be touching. That is to avoid a short. There we go. And it's a lot more difficult with the alligator clips in play. Good enough. So they are not technically touching. Yeah. Well, not necessarily what I would like to see. Okay, well, it looks like it's going to be working. So now that everything has been set up, the test leads have been attached to the electrodes are in there not touching each other, we are going to start. So the power supply is now on, and we are measuring 9 volts of direct current using the multimeter. It is actually reading 3 millivolts below, but that is really close. And the starting amperage is going to be 0.317. Okay, now we are seeing a drop to about 8.2 volts as we've reached the maximum set point of amperage of 0.42 amps. Okay, and it looks like we have now connected a short circuit as the growth has connected the electrodes. Turning off the power supply, and we see an instantaneous stop of the bubble generation. Start. Starts up again. Stop. And stops.